In this session, we're going to take a look at two more properties of exponents. Let's start with a few examples here, and once again, see if you can detect a pattern. Our first problem, 10,000 divided by 1,000 equals 10. Well, let's rewrite this problem using exponents and a base of 10. How would we rewrite 10,000? Well, 10,000 is the same thing as 10 to the fourth. And we're going to take that and divide it by 1,000. Well, how do we write 1,000 with a base of 10 and an exponent? Well, it's 10 to the third. And what about 10 as an exponent, written as an exponent with a base of 10? 10 is the same thing as 10 to the first. Let's take a look at the second example. 100 divided by 100 equals 1. Well, let's rewrite that with exponents and base of 10. 100 is the same thing as 10 to the second. And that's going to be divided by 100, which is also 10 to the second. And that equals 1, which is the same thing as 10 to the 0 power. Lastly, 1 million divided by 10,000. 1 million is the same thing as 10 to the sixth. 10,000 is the same thing as 10 to the fourth. And 100 is the same thing as 10 to the second. Do you notice any patterns here? 10 to the fourth divided by 10 to the third equals 10 to the first. 10 to the second divided by 10 to the second equals 10 to the 0. And 10 to the sixth divided by 10 to the fourth equals 10 to the second. The pattern here is that when you have the same base that's being divided in both the numerator and the denominator, your answer is going to have the same base, and then you simply subtract exponents. With multiplication of numbers with the same base, we had to add exponents together. However, when we divide by the same number in the top and bottom that has the same base, we subtract exponents. What's 4 minus 3? 1. So our answer here, 10 to the fourth divided by 10 to the third, is going to be 10 to the 4 minus 3, which is 10 to the 1, 10 to the first power. Our second example, 10 to the second divided by 10 to the second, is going to be 10 to the 2 minus 2. 2 minus 2 is 0, so our answer is 10 to the 0. And lastly, 10 to the sixth over 10 to the fourth is going to be 10 to the 6 minus 4, which is 2, 10 squared. So by those observations, we should be able to make the following conclusion. And that conclusion is what our second law of exponents states. When you have any number x and you raise it to the a power, and then you divide it by that same variable x to the b power, the result is your same base to the exponent of a minus b. And the only stipulation here is that x, of course, cannot be 0 because you cannot divide by 0. And then a and b must both be integers. With that in mind, our second law of exponents, let's go ahead and answer these couple of problems here quickly. 5 to the fourth power divided by 5 to the second. We have the same base in the top and bottom, which is 5. Then we're going to subtract our exponents. 4 minus 2 is 2. 5 to the fourth divided by 5 to the second equals 5 to the second. In a way of double checking that real quick, 5 times 5 is 25, so 5 to the second is 25. 5 to the fourth is 625. 625 divided by 25 is in fact 25. Over here, we have 11 to the second divided by 11 to the first. 11 to the second divided by 11 to the first. We have the same base in both, so our answer is going to be the same base, 11, and then we subtract our exponents. 2 minus 1 is 1. So 11 squared divided by 11 to the first equals 11 to the first. That is our second law of exponents. Next, we want to take a look at something that will lead us to our third law of exponents. Once again, when we raise a particular number to a power, it means to multiply that number times itself that many times. So let's go ahead here and take this. We have 10 to the second power, and then that whole thing is in parentheses, and we're saying that is to the fourth power. What does that really mean? Well, it means 10 to the second power times 10 to the second power times 10 to the second power times 10 to the second power. 10 to the second power is being multiplied against itself, and it is used as a factor 4 times, which is what our exponent here tells us. Well, what is 10 to the second times 10 to the second times 10 to the second times 10 to the second? Well, we have to use our first law of exponents, and that is whenever you have a number, a particular base that's raised to a power, and you're multiplying it by that another number that has the same base, you simply add exponents. 10 to the second, each of these bases here is 10. So our answer is also going to have a base of 10. And then we simply add our exponents together. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So 10 to the second, in parentheses, to the fourth equals 10 to the eighth. Can you detect the pattern? Well, the pattern is that when you have a particular number that's squared, and that's within parentheses, and then you're taking that entire number and raising it to another power, that's the same thing as keeping that base and multiplying your exponents together. 2 times 4 equals 8. The answer here is not 10 to the sixth, 2 plus 4. That would be 10 squared times 10 squared times 10 squared. That would be 10 to the sixth. But when you have this number in parentheses and it's raised to the power of 4, you multiply the two exponents together. And that's how we get 10 to the eighth. That then is our third law of exponents. Whenever you have a number x and it's being raised to the a power, and then you take that entire number and you raise it to the b power, the result is going to be the same variable, the same base x, and it's going to be raised to the a times b power. One quick example, 2 to the second parentheses to the fourth. What is that going to equal? Using our third law of exponents, it's going to be our same base, 2, and it's going to be raised to the a times b. A is 2, b is 4, 2 times 4 is 8. So our answer here is 2 to the eighth. That is our third law of exponents. And then just restating both again, the second law of exponents states that x to the a divided by x to the b is going to equal x to the a minus b, where x does not equal 0 and where a and b are both integers. And then your third law of exponents states that whenever you have x raised to a power of b, and then you're raising that entire quantity to the b power, that's the same thing as keeping your same base, x, and raising it to the a times b exponent. And the situation here is that both a and b are integers. Okay, that will end session 52.